Hello and welcome to this Shieldia guide on how to brute force the damn vulnerable web application on low security within the Tartarus lab. You can do it within your own environment as well. However, the Tartarus lab will provide you with a seam so that you can do the blue and purple team perspectives of this guide as well. So to follow along, hit up the blog at shieldia.co, and then the post is the damn vulnerable web app brute force low sec. We're covering in this post, because it's under the word limit, all aspects, red, blue and purple team perspectives. This video will only cover the red team perspective, however, and the next will probably be the blue and purple team perspectives. We're going to log in, as they say, to the damn vulnerable web app brute force challenge with 3 different tools. There is Hydra, there is FuzzFasterUFool, and the Z-Attack proxy. I give these tools as a general introduction to how you could do this. Hydra being the most common you'll see online because it supports multiple different protocols like SSH and POST, GET, all sorts of other HTTP protocols to brute force a login. FuzzFasterUFool also supports a lot of web-based stuff, so you can do POST-based logins, you could do GET-based logins, and then the Z-Attack proxy, just by way of example, that there is a way you can do this via a GUI tool, and it's maybe just a different use case for Zap, similar to what we looked at last time in the recon phase. We can also use it to substitute variables and do some fuzzing, because that's essentially what this login process is doing. It's just fuzzing multiple variables. You're going to need the prerequisites, so the red team setup if you only want to follow along with the hacking perspective, which is perfectly fine, perfectly legitimate, or the blue team perspective if your host meets the minimum system requirements, then you can follow along with the blue team side. If you just want to watch or read about the blue team perspective as well, that's perfectly legitimate. So once all of that is installed, you can begin by logging into the damn vulnerable web app and navigating to the brute force challenge. So for that, we're going to do it inside the Kali virtual machine that comes with the Tartarus lab. And we shall, oh, I'm already there. So I can just refresh that and then hit up with admin and password. I don't want to save it, thank you very much. We're going to first set the security to low, then that refreshes the cookie to the low security settings. Now brute force, which we're posed with a bit of a problem here. How do we identify which usernames to brute force? I mean, we could try some standard usernames like admin. However, we were aware that there may be some other users on the system. There are 2 methods I found that we can do this. The first method that I demonstrate in the blog is via a gitignore file. So we're going to do that. We're going to do some more because ABS, always be scanning or always be enumerating. We can, since we showed last time with the enumerating for the damn vulnerable web app subdirectory, we can then also enumerate for other directories that are being served underneath damn vulnerable web, because we didn't do a recursive. We only looked, oh, okay, here's from the root directory, here is the damn vulnerable web app, because the root directory is only serving the default Apache login page. Not the login page, just the default Apache splash page. Apologies. Instead, we're going to, with FuzzFasterUFool, enumerate some of the subdirectories underneath damn vulnerable web app. The curl-based approach, you're going to want to make sure you have an up-to-date packages. Then you're also going to want to make sure, if you're not using the Tartarus lab, to add the custom IP address so that you can resolve Tartarus-DVWA.home.ARPA to your specific custom IP address in the etc host file. If you are using the Tartarus lab, this is already done for you in the provisioning script, so you don't need to worry about it, because then all of the other commands can follow very simply. instead of replacing the IP addresses every time. So we're going to take this first command to enumerate directories under there, all of the subdirectories. Control Shift V to paste, and then begin the scan, and then wait for any, yep, done. Easy peasy. You can go through one at a time each of these directories, which is what you do in an engagement. You want to get as much information as possible. You maybe also don't want to just use the common word list. You want to use big or semi or some other word lists that are more applicable to your specific use case. You may also want to spider it with something like the Z-attack proxy. In this instance, I'll cheat a little bit and tell you it's in the git ignore file. So that's a very common place to put stuff that you don't want in other areas. You don't want in the change control. Apologies. So is git ignore even in? Git ignore should be in here. Git config, git attributes. There you go. Git ignore. Was it in the top one? No. Okay. So I wasn't in the top one, but git ignore is there. It does respond with a 200. So we're going to do a curl for the domain name. Well, specify the protocol, then the domain name, then the subdirectory that you're looking for, and then the specific git ignore file. You can see here there is a don't include any uploaded images, which is what we're going to look at today. So git ignore slash, so it won't be a subdirectory of that, it's going to be a directory from root, so hackable and then loads. We can see here, because you have to specify the directory, that's going to be like a 301 to then tell you, oh no, you have to put the slash on the end of the directory path. Don't have to worry about that. Here there's icons. Oh no, that's just to demonstrate. There is the, so this is a file from a previous test, but there's the hackable parent directory, so we can enumerate that to see what's in there, not just the uploads. In there, there's some other directories, flags, I'm not going to worry about, uploads or users. User sounds interesting, so let's have a look what's in there. We can see here that there are 5 users: Leet, admin, Gordon B, and then the other 2 users. So we now have a user list to go with our word list. That's one way to find these things. Another way is through the browser. If you log in with admin, because we know that this account works to log in, hopefully it will work in the DVWA web app. Say, okay, oh, there's a picture. Where is that picture served from? We can then go copy the image link, and then it's going to be served under users. So then, are there any other pictures in that directory? Yes, there are. So it says, again, all of their usernames, which we're assuming the file name is the username of the specific PFP. Great. So now we have a user list. There are ways to clean that up to be used in a shell script. So that's just explaining what the steps we've gone through, then the other steps. Here, there's a brief aside on how the login is actually happening. I want to make it very clear that this is not something that you may find it in production, but it's not something that you'd want to do in production, because essentially what we're doing is sending over the wire in clear text the username and password for the specific user we're trying. So these will land up in the Apache logs, and if anyone is, due to the fact that it's not HTTPS, anyone sniffing on the wire would also get those usernames and passwords. Of course, if it was HTTPS, that'd be more secure. However, just putting it via post-based login won't protect the information because it's not HTTPS. So any interception of those packets could then be easily read and the passwords identified. I mean, it's not like magic link based login and all that sort of stuff. This is like really basic, bare bones. If you want to get a clearer understanding on the different HTTP methods that are used, you can refer to the section in the previous blog post about that. We then have a little sequence diagram of how this login is happening and how we want the brute force to work. So initially we get the login to be able to view any of the resources served by the damn vulnerable web app. We then post the username, password, and user token. That will respond with the PHP session ID. Then that's what we can use then to successfully log in and view all of the resources in the password protected area, which is all of the app, well, most of the application. You will notice that here in this test, we didn't pass to get any of this. We didn't pass any credentials. So that those directories aren't actually password protected, which is also not something you want to do in production. Then we do a little loop. We'll try, okay, this username and this password, and then a successful login will display that specific text within the message response body. Then a failed login attempt will respond with that. The first tool that we're going to use is Hydra. Hydra is a very common tool that you'll see online. I'm not going to bash anyone due to the fact that they're new and just starting out. It's 100% understandable that they would make the mistake that it'll say, oh, all of these passwords are working, but not fully understanding the consequence of that in the fact that you'll see a blog post where all of these logins worked, but it's actually they didn't work and you're failing on the original login screen because you didn't pass a current PHP session ID. So that's what this sort of stuff will fix. How do you get these PHP session IDs? There are two ways to do it. There is via the web. So it's not a method that I would personally use. However, you can, in a pinch, use it this way. We'll do an inspect element. It's very similar in Chrome if you've got a Chromium-based browser, where the default Firefox also works just fine for this within Kali Linux. Then going to go to the network tab, hit it with a Control-R to reload the page. You could do a Control-Shift-R or Control-Shift-F5 if you want to refresh everything within the browser cache, but we don't need to worry about that at the moment. All we are looking for are the specific request cookies. So you can see here, this is one way you can see, oh, that's my PHP session ID. There is another way within the storage tab. Then you'll see cookies, and then how I demonstrated in the previous video, you can see security is low because we set that cookie header. Then the PHP session ID is this specific value. So you can copy this value out, and then you can use that to log in future requests. Because it's not doing any strict matching for that specific session. That session can exist over multiple instances. It's not tying that one session ID to that one browser instance. You can do it and use it however you please. Then the other way that I prefer is doing it via the terminal, because then all of the other terminal based programs can easily integrate with it. Instead of you going out and logging in, etc., you'll just get it via the terminal, and it's much easier. This did lead to some interesting findings when trying to use ChatGPT. It's not so good. It's not so good with regexes. It was doing like an improper regex extraction for some specific values, and then that did lead me down an interesting path, which I'll discuss further, in how you can brute force the main login page without the correct session IDs, like the correct tokens, the session tokens. So that was an interesting aside, but yeah, trusting ChatGPT to do some of these things, it's not really advisable. So here we've got a curl request to obtain the session ID. So we can just do a clear screen there and then Control-Shift-V again. This is quite the lengthy command. I don't like, it's not necessary that I don't like it, but doing it via the backslashes and then making like a multi-line command, you can do that. My personal style guide is when you paste it into a terminal, the terminal is going to wrap the text in any case, and then you can just read it from left to right, and it'll be fine. There's some instances where yes, I would do the spacing with the backslashes. However, here I'm not doing that. So the first thing we're going to want to do is to populate the user token. To do that, we log in, and then this creates a cookies file in the, was it the net, it's not Napster, but like the net something format, which you can edit manually yourself if you really wanted to, which is how I sort of learned about it and had to understand it. Then you're going to give your target. Now in that response, we're going to do a grep for the user token, and then that specific value. We're going to then cut that. Then using xargs, which is a way we can add arguments to commands, because this all has to run in essentially one request. You can't do a request to get the PHP session. No, sorry. You can't do a request to get the user token and then still use that in another session. If that makes sense, it has to be within a single session. So you need to use that user token that you've got from the first get request and then reuse it to be able to do the login request. Well then, so you can see we're piping each of these, meaning it's not running these commands independently of one another. It's all one big command. Xargs then allows us to do another curl request in our original curl request using, again, the C flag, and then the cookies are going to come from standard in. Then we're going to do a post request with the data for the username, password, and the user token, and then login equals login. Finally, there's a grep to get the PHP session from all of that. If we, for instance, were to remove that grep, we would see here, these are the cookie files that we were then reading. The hyphens in the man page, it'll print the cookie files to be used within other commands on the command line or in the shell. Sorry, man. There's the windows. The windows. It's like it's set right there, in the shell. The full command. If we do the full command, will just print the session token. If you wanted to look at that flow within a browser, you're more than welcome. We can do a down on web app, and then, oh no, wait. It's not Control-Shift-N. What is in Firefox a new private window? Oh, Control-Shift-P, but it would print. Anyway, down on web app. And then here we'll do an inspect element, do an admin. Now in the network tab, you'll see a post request, and then this post request has all that information that we filled out via the command line. But the browser will just do that, of course, for you, because that's what it's there for. So you can see the user token that we can grab, then the login, and username variables. So don't need, if you wanted to understand how I came up with using it this way, that's how. So we can use this specific PHP session ID to then access password protected stuff in the Down Vulnerable web app. We then break it down into 3 separate commands. First is to populate the users file. So we can, just to make everything a bit clearer, we will use this curl request because we know we don't need, it's not password protected, so we don't need to worry about getting valid PHP session IDs yet. We will get via curl that directory. We will then do a grep for any words that end in .jpeg, because those are the PFP file names. We will then sed replace to get rid of the JPEG extension, and then that will give us just the users. We will then redirect that, not with append, but with a normal redirection into a file as the final part of the, so the curl request to get the web page, the grep to get all the PFP file names, and then the sed to remove the .jpeg extension because we don't need that. And then finally redirect that into that specific file. That file could be anything as long as in the following commands you maintain the same name of that file. So we can confirm that with a cat, and then you can, in bash, there is a shortcut where it's, these are sort of like bang commands. So a exclamation point and then $sign will be the last argument of the previous command. So to then expand that, most shells would do space expansion. So after you hit space, it'll expand that. You can add that to your bash or ZSH or whatever RC files so that it makes sure it does that. Instead of copying, pasting from the terminal or doing anything like that, you can just do the exclamation point $sign for the last command of the last argument of the previous command. This will then print it to the terminal, so you can see here all of the usernames that it's able to successfully extract. We now can create a variable. If I can get the right amount of clicks, we'll create the PHP session ID variable with a the value of it will be the value of this substitution. So within bash or most modern shells, you can do a command substitution with the $sign and then open and close parentheses, or with the back tick. So to just demonstrate, it could either be like this, and then I could say ASDF equals, and then in here I'll do the date command. Now echoing what ASDF is will give me the date because it's executed that command. Just to verify, it's executed that command in that subshell. You can do something very similar, well, exactly the same with the backticks. So you could do date, and then this will be exactly the same. The way I'm moving up and down the command history, it's going to look weird on my keyboard because I've got the Vim key bindings. So my arrow keys are down, up, left, and right. That's how on your keyboard you'll just use the up arrow to go up one command. So you can go up multiple commands. You can also search the command history with Control R, but we're getting ahead of ourselves. That's just to explain. When we run this command, we are substituting the output of this, which will be, as we saw previously, that session ID string, into this variable in our shell. These are not persistent, so they'll only live for the period of this shell window being open. We can then verify that by running again the echo command, and then the muscle memory PHP ID. So we can see that does now equal a session ID. We can't easily confirm it, but it equals a valid session ID. Finally, the Hydra command. That's the wrong terminal window. This is the right terminal window. Let's actually clear it, and then we can explain what's going on here. Hydra, again, used to brute force applications. Very popular, very powerful. We're giving it the target of the Tartarus damn vulnerable web app. We're giving it a capital L for user list. You could use a lowercase l if you just want to give it one username, like admin, for example. We're then using the capital P for the password list. However, in this instance, it won't work because if we do a ls user share, here again, it's just tab completing. RockU, because the RockU word list is so big, it gets compressed in the initial installation of Linux, Kali Linux. So we want to unzip that file. Is there an easy command? Yep. Gunzip to unzip it or uncompress it, but maybe more appropriate. We can then use that. It's sudo because it's in as special permissions. So now that will deflate the file so that it'll be the full proper word list and not the compressed version. Now we can run this. So you can select Control-Shift-C and then Control-Shift-V. This will now succeed. So we've got the correct word list. We've got then the specific type, the protocol we're instructing Hydra to use is HTTP GET forum. Here it's a bit more wizardry. We define the directory that the login form will be located in. We define the variables for user, then cache the specific user parameter, ampersand password, cache the specific password variable that we're substituting with each of these requests. The header, then this is the sort of space, so there's spaces between these things. The cookies, we want to set the security to low. Then we want to finally incorporate the PHP session ID. So this is a variable that we just filled in. We'll now substitute through the command substitution to be the right PHP session ID. And then finally, we want to specify how Hydra should know that login has failed. It will see this in the response body. It's not perfect. Like I've said previously, if there's a failure somewhere else in the chain, like you don't have the correct PHP session ID, it will look like the logins work. I will briefly demonstrate that now. If my PHP session was everyone's favorite, ASDF, this is going to look like, oh, it's working. It's working. Oh, great. There's so many good passwords. But it's not actually working because it's failing on the first step, which is it'll be redirected to the login page and then the main login page and fail. If we try this, however, it will then go through and in some time print out the correct passwords to the screen. I might skip ahead, I might not. And there we go. We have the usernames and then in the same line which password successfully logged into that account. We can also see the substitution happening correctly here. It's saying PHP session ID is the variable that we filled before. Now any of these would grant logins to both the main login section and then the login for that specific user in the brute force challenge. There you can see we've explained that. Now with the ZAP, the Z-Attack proxy, I'll briefly demonstrate how we could do a similar process with that. Again, you're going to want to install it. Installation steps are sudo apt install ZA proxy for the Z-Attack proxy. We're going to not persist the session at this time. We can do a manual exploration for launch the browser. So we've inputted where we want the browser to open. Then we're going to input the specific directory we want. Now we can say admin password. So this in the background Zap is just saving all of these fields. We're then going to go to the brute force section, input a dummy username and a dummy password, log in. Oh, I'm on the impossible difficulty, so that's not going to work. Instead, if this happens to you, the best approach is actually just to reset the database, because that'll then unlock the accounts. Now, setting the security to low, we then log in with the dummy credentials. Log in, username and password incorrect. Awesome. Now that we have that filled in for us, we can open the specific request that we made, which would in most instances be the last one in this list here in the history tab. We can then double check, yes, that is correct. So this is what the browser is doing in the background for you, is it's going which method to use, the target, all of that stuff is done for you. We want to then add this request to the fuzzer. So right click, attack fuzz. We could just select ASDF, add, and then we want this to be, we could be a strings. If you go back here, no, wrong window again. If you go back here, cat, the damn vulnerable web app users, Control-Shift-C, Control-V to paste that in there. Now we have the username list. Great. We can OK that. We want to then modify this, add as a file. We can then browse to that file. It will be under user share word lists, which is sort of at the end. Word lists, and then RockU should be right there. We can then, we're not going to, I mean, you can limit it really, in reality. We'll limit it to, say, 10,000 lines. Or let's say actually 50, we'll say 50,000 lines, just to keep it simple. Now, those are the two variables we will be fuzzing within the get request. So similar to how Hydra would have been doing it, it's going to say, okay, the first item in the username list with the username filled in as 1337 or delete, and then trying it with a item within that directory, within that word list. So it will be, I mean, the first password in RockU is password, isn't it? I think. We're going to do a head n10, so the top 10 user share word list RockU. Okay, 1, 2, 3, 4, 5, 6. If that's your password, then good luck. So it'll try that username, that password. Then it's going to go, okay, that's failed. It'll try the same username and then the next password down the list. Same username, next password, same username, next password, until it either exhausts the entire word list or it finds a successful response, denoted by the message body that we get. Here, we're not going to be doing that level of filtering. It's going to be attempting all of these, and then we can do filtering on the back end. So we're going to say start fuzzer, and then I'm going to move myself to the other side of the screen so that you can see here in the payload section exactly what I was explaining. It's trying the username and then that specific password for that username. I'll be back once this finishes. As I've corrected in the video, use the top 5,000, not the top 50,000. Now we can look for the results. There are two ways. There's the way that I demonstrate in the blog post, which is using an inverse search. However, you don't have to do this. You could also search for the welcome to the admin, to the password protected area, and then whichever username tries to log in. From the fuzzer tab, go to history and then, go to search and then search for welcome in the HTTP fuzzer results. Here you will see a list of all of the pages with that specific word on them, meaning that they succeeded. You'll see the username and the password for each of those. So that is how we can do a brute force via the Z-Attack proxy. You don't necessarily need to do it, but that is just another tool within your arsenal. Finally, using fuzz faster ufull, we can do something very similar to what we did with Hydra. We will first seed the users file with the correct contents. So I'm just going to close and then quit that session. We will clear the terminal and then I will move myself back. Here again, this fills the file with what usernames you want to test, as explained previously. Then we seed the PHP session ID. We might get away with using an old session ID, but it's best practice to use a new session ID because they can time out and then you'll get inconsistent results. And finally, the command for fuzzfastufull, we're giving it the URL that we want to attack. We're going to then pass it some parameters for username equals user, password equals pass, login equals login. We're going to stipulate a match condition of 200. We're going to filter size by that size. We're going to filter results by the username and or password incorrect. We're going to allow redirection. We're going to, since this is a post request, we're going to specify the data that should be within the message body. Security low, the PHP session ID that we have already filled in, which word list for which variable. So here we are specifying the word list of the damn vulnerable web app users.txt that we created is the user variable as opposed to just the standard fuzz variable. Then again, which word list for the pass variable. We can then fire that up and already it's come back with 2 successful words because it's rapid. The reason we're doing some filtering responses is how we are requesting this. If any of the passwords have octothorpes in them, how we've structured this request, it will ignore the login section and what the actual password value is. This is a standard browser feature. It will then show you a successful login, but it's not actually a successful login. So we can now, we have 4 of the 5. Just going to wait for the final one. Then we will have all of the usernames and passwords with 3 different methods that you could employ for brute forcing a target that you have authorization to brute force, of course. We shall wait a little bit. There we go. All of the usernames and passwords. You have to, because the way fuzzfastufull is going to try all of the different combinations. Once you have what you're looking for, just Control-C and then that will stop the process. We can now save this information wherever you want. That is all of the aspects that I wanted to cover in regards to the red team. In the next video, we will cover the blue team perspective on how we will be able to detect that activity. See you in the next one and have a good one. Bye.